Here's problem number 5 from the 2011 AP Calc AB, and also this was on the BC exam, so this is another problem that overlapped on both exams. And it's a non-calculator question, and the problem setup tells us that we have a landfill that initially contains 1,400 tons of solid waste. The increasing function W is going to model the total amount of solid waste stored in the landfill. They estimate that W will satisfy this differential equation for the next 20 years. W is measured in tons, T is measured in years from the start of 2010. In part A, they want us to try to predict how much waste will be in the landfill at the end of the first 3 months of the year 2010. So since T is measured in years, 3 months out of a year would be 1/4 of a year. So we want to estimate with a tangent line at T equals 0 how much waste is going to be in the landfill at T equals 1/4. So I realized that to find the equation of my tangent line at T equals 0, I'm going to need to know the slope of the tangent line at 0, or dw dt at T equals 0. And this is a little bit tricky because what's tempting to do, since we're so used to it, is just take the value of the independent variable, which in this case is 0, and put it there and go with that for our slope. So if we did 0 minus 300, our slope we might mistakenly say is 1/25 times negative 300. But W is the variable within this derivative. And W, whenever T is equal to 0, is 1,400. So if we want to find our slope, we actually have to put 1,400 in place of the W in the derivative. And then if you simplify that, you end up with a slope of 44. The point of tangency was already given. It was actually 0, 1,400, the initial amount of waste in the landfill. And so if you recognize this as the y-intercept of a line, you can go ahead to slope-intercept form directly and realize that your slope is 44, your y-intercept is 1,400, and then W of 1/4 can be approximated by taking 1/4 and tossing it in place of the x in the equation of your tangent line. And if you simplify that, you end up with 1,411 tons of solid waste after the first quarter of a year. In part B, they want us to take the second derivative with respect to T and then use it to try to determine whether our estimate was an overestimate or an underestimate. So I took the derivative of the left side of this with respect to T, and I got my second derivative. But then when you take the derivative of the right with respect to T, you're going to have to be really careful because you're going to have to use implicit differentiation. This W is something that changes over time, so it's a function of time. So when you take the derivative of 1/25 W with respect to T, you get 1/25 dW dt. Now the derivative of minus 12 does go to 0 like it normally would, but then this would be the derivative on your right-hand side. And then you know what dW dt is. dW dt is equal to this, or if you'd prefer, is equal to this. And so what I went ahead and did was I went and I tried to figure out when dW dt would be negative. And I figured out that dW dt would be negative when W is less than 300. Right? This is positive, so I basically was trying to figure out when this quantity was negative. And I guess if I would have used this form of the derivative, it would have been a little bit more obvious. If W is less than 300, if W is 200, 200 minus 300 gives me a negative value here. And that would make the second derivative negative. So I knew that this graph was going to be concave up since W is going to begin at 1,400 and grow larger. So our graph is always going to be concave up. So what I did was I kind of drew something that was concave up, and then I put a tangent line up against that graph, and to the right of the point of tangency, the curve is going to be above the tangent line since the graph is concave up. So our estimate is going to end up being an underestimate because our y value on the curve is going to be slightly below the y value on the y value on the line is going to be slightly below the y value on the curve at the same x value, since the slope of the tangent line is increasing drastically when your curve is concave up. And then in part C of this, you're asked to find a particular solution, and more often than not, when you're asked to find a particular solution in one of these free response questions, it actually ends up being worth 5 of the 9 points. So it's definitely something that you're going to want to try and do your best with. And the first thing that you would have to do, and the first thing that you'd receive a point for, would be separating your variables. So I separated my variables by dividing each side by this set of parentheses, multiplying each side by dt. Technically, I had to do a u substitution here. I had to function in this denominator, so I let u equal that function in the denominator. Now du dw ended up being 1, so du equaled dw, and I ended up with a pretty simple antiderivative, just the natural log of the absolute value of u. And then when I back substituted w minus 30 in place of this u, I ended up with this expression here. The integral on the right was a little bit easier. You end up with 1/25th t to the first divided by 1, or just 1/25th t, and then that's the side you want to put your plus c on. So the point breakdown here of the 5 points, like I said earlier, you get a point for the separation, you get a point for the proper antiderivatives, you get another point just for tossing in a plus c. You typically get the 4th point for solving for the dependent variable, and the dependent variable is w. And then you get the last point for applying the initial condition and solving for your constant of integration. So what I did in this right-hand column here was I exponentiated each side of this equation. The left side, I still have absolute values around, because if you look at the right side, if I rewrite this addition within the exponent as multiplication of like bases, e to a power times e to a power is only going to be positive. So the absolute values have to still be on this line in order to ensure that the left hand of my equation, what I have over here, is still also allowed to only be positive. But then the second I say e to the c is going to be replaced by some arbitrary constant a, I've now given the right side of the equal sign a way to become negative, and then I can also allow the left side of the equation to become negative by dropping the absolute values. And then if I added 300 to the other side, this would be my general solution. Put 1400 in for w, 0 in for t, that's the initial condition, and then take a minute to solve that for a, and you end up with 1100 for a, and there is your solution.